Hi, in this lesson, we'll take a look at the anatomy of classes. Let's go. In previous units, we learned how to write method declarations. Each method declaration contains keywords that are used to indicate how that method can be used. While we've spent a lot of time discussing the return type and the parameters that go into a method declaration, we haven't discussed in much detail the access specifier. In this lesson, we are going to dive a bit deeper into what the access specifier does and how it can be used in our programs. The access specifiers determine whether classes, data, constructors, and methods can be used outside of the declaring class. There are a few different access specifiers, but the ones that we will focus on in this course are public and private access. Public access, which we've been using for all of our methods up to this point, allows access from classes outside the declaring class, while private access restricts access to data and methods to the declaring class. What do we mean exactly when we say that access is restricted to the declaring class? When methods, constructors, and instance variables are created in a class file, they are considered declared within that class file. The declaring class simply means the class file that the constructor methods and variables were created in. Any methods, constructors, and variables that are made public can be used in other class files. In this case, we can use public methods written in rectangle.java in our myprogram.java file. When a method or variable is considered private, they cannot be used in other files and can only be called within the file that they were declared in. myprogram.java cannot use or call any private methods or variables created in rectangle.java directly. Because we generally want our class files to be used by others and in other files, classes and constructors are designated as public so that they can be accessed outside of the class file. This is why we can call a constructor for rectangle in myprogram. If we were to change the access of the rectangle constructor to private, we would be unable to access the constructor, as the private designation means that it can only be used within the rectangle.java file. This would make it impossible to create new rectangle objects in other files, which is why constructors are generally public. So why would we want to make any of our data private? We use private access for methods and data in order to manage complexity by controlling how users can interact with objects and hiding implementation details that are unnecessary for users. This process of hiding the implementation details of a program is referred to as encapsulation. This is one of the core tenets of object-oriented programming. The definition of encapsulation seems rather similar to that of abstraction. While the two concepts are similar, the difference between the two is that encapsulation is more concerned with hiding the internal state of an object, such as its instance variables, whereas abstraction is concerned with hiding the details of how something works on a wider scale. Abstraction revolves around the idea that we don't need to know how something works in order to use it, while encapsulation suggests that data about the object doesn't need to be shared in order for it to be useful. Generally speaking, we make the instance variables in our programs private so that the data stored by an object cannot be easily manipulated. If we didn't make instance variables private, their internal values could be changed easily from other files. In this case, if the instance variables width and height were public, we could manipulate their value by calling rect.width or rect.height and make changes directly to the object. When we set the instance variables to private, users can no longer change the values of width and height directly. As a side note, for any instance variables that are public, we can actually access their values directly by calling the object name dot and the variable name. This will locate the object variable and return its value. Let's look at a more obvious example. Suppose we created a student class where the attributes that we wanted students to have were eyes, hair color, and eye color. We initially set the value of eyes to 2 because we anticipate that all or most students will have 2 eyes. We also make sure that students can only input the value brown or blonde into the hair parameter. This is an example of encapsulation in action. We hide the data relating to eye and hair color so that any changes made to these features will not affect the user experience directly. If we leave these values public, however, then those values can be manipulated and changed. A user could set the value of eyes to be 100 and change the hair color to cat. If we created additional methods that used the values of hair color and eyes, then the rest of the object and its methods would be compromised by these changes. We can avoid users from setting these values by making these instance variables private. Rather than allow users to manipulate data directly, we use accessor and mutator methods to control what aspects of an object that users can alter. We have previously created get and set methods in our programs, so this should be familiar. These are used in place of directly accessing the object's variables so as to simplify how users interact with objects. Programmers often have to make decisions about whether or not data should be accessible, modifiable, both or neither. Depending on your product, program, and relation to users, what you choose may differ. You may want your data to be accessible and create accessor methods that allow users to receive info about the objects they interact with. You may want them to be able to modify their data, in which case you may create a mutator method or allow them full access to change the value by making it a public variable. Or you may want data to be both accessible and modifiable. This could be achieved by providing users with both accessor and mutator methods. Or lastly, you may not want them to access or modify it at all. In that case, you may not create any methods to access the data and keep the variable private. Now that we know a bit more about access, let's use this to think about how we might construct a savings account class. Imagine you were tasked with creating a program that created a savings account and kept information about that savings account. What are some potential methods that we would want developers to have access to? Another way of thinking about this is, if a developer were trying to create a savings account app, what methods should be available to them so they can do so? When you use a savings account, what features do you expect? If we were creating a savings account app, we would probably want users to be able to check their account balance, deposit money to their accounts, withdraw money, and get a sense of their transaction history. Each of those would be methods that users implementing our methods would need access to in order to create an effective savings account. Now, what are some of the methods that users might not need access to as they are using the savings account? In other words, what are some methods that can exist behind the scenes that users might know about but don't need to see in action or use? Some methods that users may not need to be able to access might be adding interest to money in a savings account or how long that account might be open. These methods are very important to having a working savings account, but users may not need to know how the interest is calculated or worry about adding interest to a savings account on a regular interval. It's important to note that oftentimes, setting methods to private isn't a matter of trusting users to use our programs appropriately, but more so that they don't need access to these methods in order to use the class files correctly. If the savings account file adds interest to savings accounts at specific intervals, or when the account is accessed by users, then users don't need to have access to that method, as it is already being implemented without their intervention. As stated earlier, private methods can only be used within the class that they are declared in. That means that they can be used in other methods within the savingsaccount.java file. Perhaps there is another method called checkInterest that adds interest to the savings account once the account has been opened for 30 days or longer. We can use the private method daysopen and addInterest in our checkInterest method because they were both created in the same file as checkInterest. Now that you've learned about access specifiers, let's get some practice using them in the editor.